When we started to work with sugarcane and second generation in Brazil, we didn't know anything about the cell wall. We didn't know any of the linkages of the polysaccharides, nothing about it. So during the last 10 years, we started studying the structure of the polysaccharides and how they are arranged in the wall. And we discovered that there are at least 24 different linkages that have to be broken. Every linkage needs an enzyme, right? So, but not only one enzyme for linkage, because depending on how the polysaccharides are bound to each other, you need different enzymes. So there are at least 50 enzymes we know already that are related to the hydrolysis of the cell wall. We look at how fungi and bacterial enzymes can act on a cell wall. This is important that you can use that in industry. But we are more interested in learning processes that occur inside the plant, that the plant uses to hydrolyze the wall, so that we could prepare the plant in the field so that the plant, when it goes to the industry, would need less enzyme, because the enzymes are very expensive. So what we did was to look for places in sugarcane where the cell wall was being degraded naturally. We looked at first at the leaves, but we didn't find any degradation of the cell wall. And then we found a degradation process in the roots. And the roots have cell walls that are very similar to the stem and to the leaves. So we started studying in many different ways how this process takes place. And we already found at least 50 enzymes that are sugarcane enzymes. Of these 50 enzymes, we were able to search in the very complex genome of sugarcane, and we found the alleles, at least for 2 of them, that are important in the process. And we already have transformed plants that we expect to be able to hydrolyze the walls a little bit better. We don't want to fully hydrolyze the wall, but just soften the wall so that we would have a biological pre-treatment and the plant better prepared for the second generation bioethanol. We believe that this could decrease cost of the process. In parallel, what we are doing is to search for genes that the plant already has to respond to the environment and modify the wall. So instead of having transformed plants, we are going to use the knowledge of the geneticists to try to find varieties that are naturally more amenable for hydrolysis, and that could be used in industry. So there are 2 different ways to get to the same place.